Hello everyone, I welcome you all to the lecture 5 of this course, Construction Methods and Equipment Management. So in this lecture 5, we will be discussing about how to estimate the total equipment cost. Okay, so far we have discussed about how to estimate the ownership cost and the operating cost components. Okay, so in this lecture we will be working out some illustrations on how to estimate the total equipment cost using Caterpillar method and Purify method, which are the commonly adopted methods. So let us have a recap of what we learnt in the previous lecture. So in the previous lecture, in the lecture 4, discussed about the different operating cost components. Okay, so we have looked into how to estimate the various operating cost components of the equipment. Now let us see the outline of today's presentation. In this presentation, we will be discussing the stepwise procedure or how to estimate the equipment cost using Caterpillar method and the Purify method. Okay, and we will be working out some illustrations using these two methods on estimation of the total equipment cost. So as I told you, these are the two commonly adopted methods. One is the Caterpillar method, other one is the Purify method. So we are going to discuss this procedure as discussed by Gandhinagar et al. So I have referred this textbook and it is included in the list of references which will be shared with you towards the end of the presentation. So let us see now the stepwise procedure of the Caterpillar method. Okay, so this procedure you can also find it in the Caterpillar Performance Handbook, which is published by the Caterpillar Equipment Manufacturing Company. So it's a very popular method. So as we know, the ownership cost and operating cost are the two main components. Let us start with the estimation of the ownership cost. So under the ownership cost, we are going to estimate the depreciation first. So in this Caterpillar method, we are going to adopt the straight line method for estimation of depreciation. I hope everyone remembers what is the straight line method of depreciation. So how to estimate depreciation using straight line method? It is nothing but the difference between your initial price minus the salvage value. So obviously I have to deduct the tire cost also, because tire cost will be considered separately under the operating cost. So depreciation is nothing but initial price minus the salvage value divided by the depreciation period in hours. So it is nothing but your useful life of the machine. Okay, useful life of the machine. So we are assuming that your machine is going to depreciate over the useful life. So that is why it is written as depreciation period in hours. So this is what is the period we take it for the cost accounting purpose. So you can call it as useful life or service life or the recovery period or the depreciation period. So there are different terminologies to call the service life of the machine. So this is how you calculate the depreciation. You can get the hourly depreciation. Now let us calculate the other components of the ownership cost. So nothing but the cost of investment, taxes, insurance. So everything will be calculated as a percentage of the average value of the equipment. Okay, I hope you remember. So how to estimate the average value of the machine using straight line depreciation method. We have derived this formula in the earlier lecture. It's nothing but P into n plus 1 plus S into n minus 1 by 2n. Your P is the purchase price of the machine and S is the salvage value of the machine. In this purchase price, you are supposed to deduct the tire cost, because the tire cost will be considered separately. Okay, deduct the tire cost. N is the useful life of the machine. So you can calculate the average value of the machine over the useful life of the machine using this formula. Then after that, you calculate the cost of investment, taxes, insurance, everything as a percentage of this average value of the machine. Now the ownership cost is done. Let us move on to the operating cost. So under operating cost, we are going to discuss the cost of consumables. Firstly, we will discuss about the fuel cost. Fuel cost, there are different handbooks which provides you the information on the fuel consumption factor. Fuel consumption factor, you can get it from different handbooks. So different handbooks are available. Actually in the real life, we are supposed to have some accounting records, like you may be having your past records about the performance of your machine. So from that also you can get the fuel consumption factor for the similar machine, or you can go by the manufacturer guidelines as mentioned in the equipment handbook supplied by the equipment manufacturer. So that will also serve as a guideline to find the fuel consumption factor. So basically, as I told you, say for example, if you look into Caterpillar Performance Handbook, okay, Caterpillar Performance Handbook, in that case, they have given the hourly fuel consumption for different models of machine. Directly you can get it. Hourly fuel consumption is provided for the different models of machine manufactured by them. So directly you can get the hourly fuel consumption, and they have defined the load conditions, for different load conditions. Okay, for different load conditions, they have given the values. Say for example, I remember we discussed this example in the earlier lecture also. Say for example, the excavator, if you take a particular model of excavator, for different load conditions, say high load condition, medium load condition and low load condition. What is the fuel consumption, hourly fuel consumption? You can get the values from the handbook, Caterpillar Performance Handbook. Say, and they have defined the load condition also. For high load condition, it means your excavator, say for example, it is working in a rocky terrain. So you mean the fuel consumption or the power consumption will be more in a tough condition. Similarly, the equipment is working for a longer duration. Say it is digging at a 95% of the daily work schedule. It is digging at 95% of daily work schedule. It means your fuel consumption is more. It is working for a longer duration, and since it is a poor rough terrain, it will be working at full power. Okay, so that's why we call it as high load condition. Similarly, for the low load condition also, they have given the definition. Say for example, it may be working in a sandy terrain. So handling the sand or common earth, it's going to be easy for the excavator. So the power consumption or the fuel consumption is going to be less. Similarly, it may be digging at less than 50% of daily work schedule. 50% of daily work schedule. That means its working duration is less. So accordingly, your operating cost will be less. Okay, that is why they are calling it as low load condition. Similarly, different equipment models. So they have given the fuel, the consumption, hourly fuel consumption for different load conditions along with the definition of the load conditions. So you can go through it. Whichever load condition is matching with your actual project condition, okay, you can take it accordingly and use those values. It's not only the Caterpillar handbook. So every equipment manufacturer, whenever he supplies his machine, he provides information on the machine. So manufacturer guidelines are there. So from those guidelines, you can get this information. So in some handbooks, they directly give you the fuel consumption factor. Instead of giving hourly fuel consumption, they give fuel consumption factor for different working conditions. Say average working conditions, severe working conditions for different types of machines. So it is also expressed in this way. So depending upon the equipment handbook, you can see the way it is expressed, it will be different. So directly you can take the fuel consumption factor to the project working condition, multiply it with the horsepower of the machine and multiply by the unit fuel cost, you will get the fuel cost. But in the Caterpillar Performance Handbook, you are getting directly the hourly fuel consumption for the particular model. So you need not even multiply it by the horsepower of the machine. You can directly use the fuel consumption value, multiply it by the unit fuel cost, you will get the hourly fuel cost for the particular model manufactured by them. So depending upon the handbook, you have to go through it carefully and make the estimation. Okay, there cannot be a common rule for every handbook. And another important thing is FOG. FOG is nothing but filter, oil, grease. Okay, so these are also the consumables which are consumed during the equipment operation. So if you look into Caterpillar Performance Handbook, you can see, as I told you, the hourly consumption of the filters, hourly consumption of lubricating oil, hourly consumption of grease is available for different equipment models, for different operating conditions. Directly you can take it, multiply it by the unit cost. You will get the FOG cost. Okay. In some other handbooks, you can see that they give it as a FOG factor. Factor in the sense, you have to multiply this factor by the fuel cost. It will be expressed as a percentage of the fuel cost. In addition, you have to apply some labor adjustment factor also to get the accurate value. Labor adjustment factor. Because as you know that the labor skills, depending upon the operator skill, the labor skill, all these operating costs will vary a lot. So that is why, and this labor skills will vary from region to region, from place to place. So in some handbooks you can see for every region what is the labor adjustment factor, that is also available. Accordingly you can adjust your FOG factor. So there are different approaches to estimate these costs. So depending upon the handbook you are referring, so the approach may vary. And another thing to be calculated is your tire cost. It is nothing but your tire replacement by the estimated life of the tires in hours. So this you can get it from your manufacturer. For different work conditions, for different terrains or different operating conditions, what will be the estimated life of the tire of this machine. You can get it from the manufacturer or from your past records. And similarly, your tire replacement cost, obviously you can get the cost of the tires easily. So you will get your hourly tire cost. So for the tire, you can add the repair cost. You can add just 15% to the tire replacement cost. That will give you the tire repair cost. So another thing is your repair of your machine other than tires. So maintenance and repair of your machine excluding the tire cost. So the tire repair we consider separate from the repair cost of the remaining part of the equipment. So for the repair cost estimation of the equipment, so you can follow this methodology, like you can take the repair factor as a percentage of the initial cost of the machine, but excluding the tire cost, as a percentage of the delivered price of the machine excluding the tire cost. So that will give you the repair cost. These factors you can get it from the literature, okay, for different project conditions, or you can get it from the equipment handbook. As I told you, in Caterpillar handbook you can see that for different ranges of operating hours, these repair factors are given. Say for example 0 to 10,000 hours, you can get a repair factor, 0 to 20,000 hours, operating hours of the machine. So accordingly your repair factor will vary. So you can get these values accordingly depending upon the handbook you are referring. So finally divide it by the annual usage of the equipment in hours so that you can get your hourly repair cost. So now the total ownership and the operating cost will be the sum of all the ownership cost components, operating cost components, and in addition you have to add the operating wages, as I told you earlier. So the daily wages what you pay for the operator, okay, I mean the hourly wages for the operator, in addition to all the benefits he gets like the bonus, the overtime benefits, and even the workman compensation premium which we pay on behalf of him. Okay, so all those things will be included in the operating wages. So with this the Caterpillar method is done. Now let us move on to the stepwise procedure of the Purify method. Purify is a very popular method. So he is a very famous person. He is even considered as the father of the modern construction engineering. His contribution towards the construction engineering and the construction equipment and the equipment cost estimation is highly appreciated by many people. You can see his approaches are very rational. So let us discuss his guidelines also on how to estimate the equipment cost. Okay, coming to the ownership cost. Under the ownership cost, we are going to calculate the depreciation. Here also, we are going to follow the straight line method of depreciation. And in Purify has discussed two different approaches. One is your average annual investment method, average annual investment method, and the other one is time value method. So you can see there are two approaches discussed by him. So under the Caterpillar method, we have discussed this approach already, average annual investment method. Okay, so we are not going to discuss it again. Okay, so this method is really approximate. Okay, because we are not considering the timing of the cash flows which are occurring at different point of time. So that is a limitation of this method. So in this Purify method, now we are going to discuss only the time value approach. So here we are going to consider the timing of cash flows, which gives you more accurate estimation of the cost. So we will make use of the different compounding factors to convert the cash flows occurring at different time period into equivalent value at a particular time period, as discussed earlier. Okay, so we are going to discuss only that approach in the presentation now. So if the timing of cash flows are considered, how to do that, we are going to discuss now. So initial cost of the machine, that is the purchase price, so that we are going to convert it into equivalent uniform annual cost using uniform series capital recovery factor. So we have discussed the application of all these factors already. So you can convert your the initial purchase price into equivalent uniform annual cost using uniform series capital recovery factor. So this is a uniform series capital recovery factor. This is your initial cost. You multiply both, you will get your equivalent uniform annual cost of your purchase price or the initial cost. So here you are supposed to deduct the tire cost, because tire cost will be considered only under the operating cost. And the next one is your future salvage value. Okay, the salvage value, it is converted into, salvage value is converted into equivalent uniform annual cost using uniform series sinking fund factor. Uniform series sinking fund factor. Your salvage value is converted into equivalent uniform annual cost over the useful life of the machine using uniform series sinking fund factor. So you just multiply the salvage value into uniform series sinking fund factor. Okay. Now, the hourly depreciation you can calculate using the straight line depreciation method. Just the difference between the equivalent uniform annual initial cost, okay, equivalent uniform annual salvage cost, okay. So, that will give you the depreciation divided by the annual usage of the machine in hours. So, you can get the hourly depreciation cost using this straight line depreciation method. So, we are just trying to recollect or summarize again whatever we have discussed in the earlier lectures. So, I hope you remember the applications of all these factors. So, using this time value concept, we have estimated the hourly depreciation accurately as seen in this slide. Okay. Now, you calculate the other components of the ownership cost, which are nothing but your taxes, insurance and storage. So, they are calculated as a percentage of the initial price minus the tire cost. Okay. So, initial price minus tire cost. Okay. So, you can calculate it, okay, and your taxes, insurance, storage are calculated as a percentage of this. So, in the earlier caterpillar method, hope you remember, when you adopt the average value method, you have to take all the taxes, insurance, storage as a percentage of the average value of the machine. Okay. So, here we are considering it as a percentage of the initial price of the machine. Now, coming to the operating cost. So, equipment fuel cost. So, you can calculate it based upon the fuel consumption. Okay. So, this fuel consumption you can get it from the your past records or any equipment handbook or manufacturer guidelines. Okay. So, whichever manufacturer supplied the equipment, so they will be providing some guidelines as a handbook. In that handbook, you can get the information for the particular model on the hourly fuel consumption. Okay. So, directly you may get the hourly fuel consumption for the different project conditions, or you may be getting the fuel consumption factor, okay, for the different project conditions. So, accordingly you have to use it. Say for example, if you have used some value from a literature where the values are given for some standard conditions, where the machine is working at maximum output rate, okay, then you have to adjust that particular consumption factor according to your project condition. Okay. So, that combined factor is nothing but your operating factor. It is nothing but your operating factor which reflects your project conditions. So, according to your time factor, according to the load factor, okay, so you have to adjust the fuel consumption value taken from that particular literature. So, to multiply it by the operating factor so that you can get the consumption for your project conditions. So, then you have to multiply by the horsepower of the engine and the unit cost of the fuel. So, this will give you the hourly, okay, equipment fuel cost. So, it depends upon the source of your literature, okay, from which handbook you are taking the information. So, according to that, the approach may slightly vary. Okay, but basically you have to make sure that whatever factors you use, it should reflect your project condition. It should not be too theoretical. It should not be a value which was derived for standard conditions. So, you have to adjust it according to your project conditions so that you can get a realistic estimate of your equipment cost. So, the next is your other consumables, your FOG, okay, as we discussed just now for the caterpillar method. So, you can get the FOG factor as a percentage of fuel cost, and you can multiply it by the labor adjustment factor. So, this labor adjustment factor will vary from region to region depending upon the variation, the skill of the labor, which is also going to affect your operating cost significantly. So, these values are available in some particular handbooks, which I have listed in the references, you can see. So, you can make use of that to make the adjustment accordingly. Okay. Or some handbooks, as I told you, it directly gives you the hourly filter cost and lubricating oil cost and grease cost. You have to, for the different project conditions, you have to just simply multiply it by the unit cost so that you can get your FOG cost. So, the approaches are different. And the repair and the maintenance, they are expressed as a percentage of the depreciation cost. So, this is also one way to express the repair and maintenance, as we discussed earlier under the operating cost. So, another thing is the tire use cost. It depends upon your tire cost, okay, and the estimated life in hours of the tire, which you can get it from the equipment manufacturer. And the tire repair cost is expressed as a percentage of the straight line depreciated tire cost. So, you just add up everything, the ownership cost, all the operating cost and the operating wages also, you will get your total ownership and the operating cost following the purified guidelines. Now, let us work out some examples on how to estimate the equipment cost using these two methods. So you can see this problem. In this problem, we are going to estimate the cost for a dump truck. Okay, it is a off-highway truck. So why we call it as off-highway? This the truck is not permitted on the public highways. It's a heavy equipment, high-end equipment. So you can see that these highways, these trucks will be operating only in the project sites, or you can also see in some quarry truck. Okay, so those heavy machines are not permitted on the public highways. Okay, that's why they are called as off-highway trucks. The initial cost is given. So it was purchased at a delivered price of 3 crores. So you can imagine it's a very high-end equipment with special features. Like you can see, it will be a kind of articulated machine. Okay, with many additional features are there with this dump truck. That's why it can justify its cost. And the tire cost of this machine is 11 lakh. So many of these numbers I have just made some approximate assumption. So let us not go deep into these numbers. The main objective of this illustration is just to show you the methodology of how to estimate the equipment cost. The requirements are according to the type of the machine for which you are going to estimate. You can choose the appropriate equipment handbooks and choose the values and estimate it accurately. These numbers are just approximate assumptions just to show you the methodology how to estimate the equipment cost. So the other associated cost or the interest rate, which is nothing but 8%, insurance 2%, and taxes 3%. So other components of the ownership cost are given, and the truck is expected to have annual use of 1600 hours. So every year the truck is operating for 1600 hours. It depends upon every day how many hours it is operating and how many days it is operating in a particular year. So according to that, you can calculate this 1600 hours. Similarly, throughout the entire life, its useful lifetime, the hourly usage is 20,000 hours. And the local cost of the fuel in that particular place is 65 rupees per litre, and the operating cost, the wages per hour is 200 rupees per hour, and the horsepower of the engine is 250. And the expected life of tire, this data is given to you directly. You can take it from the handbook according to your requirement. Okay, but I have given you some approximate number for average working condition, nothing but 2100 hours for this particular tire. Then the diesel consumption of the truck for average working condition is 0.09 liters per hour per horsepower. So this value also I have assumed it approximately. Okay, you can look into the literature for the particular type of the machine in particular work condition, and you can get the value accurately for the particular model of machine from the equipment handbook. And similarly, filter oil grease, I have given the factor 0.119, and the labor adjustment factor I have used it as 0.8 approximately. Okay, I have made the assumption for the particular region. Take the salvage value as 0 for this particular problem, and the annual repair cost is 6% of the initial cost, excluding the tire cost. The repair factor is also given to you directly. So for the above dump truck, you calculate the total cost, your ownership plus operator cost by the Caterpillar method first. Okay, we are going to estimate it by Caterpillar method first. So the ownership, under the ownership cost, let us calculate the depreciation first. So we are going to follow the straight line method. Since the salvage value is 0 here in this problem, so depreciation is done to 0 value. You can see that it's nothing but initial price minus tire cost minus salvage value is 0, divided by the useful life of the machine. How to find the useful life of the machine? So they have given you the total expected use of the machine in lifetime. Okay, it's given in the question, so you can recollect. The total expected use of the machine over its lifetime is, so you can see the total expected the use of the machine over its lifetime is 20,000 hours. So it's given to you. Okay, and the annual use of the machine every year in hours is 1600 hours. So if you divide both, you will get the 20,000 hours. It's a total the lifetime use in hours. Every year it is used for 1600 hours. This will give you the useful life of the machine in years. Okay, that's what we are calculating here. 20,000 divided by 1600 gives you the useful life of the machine in years, 12.5 years. Now we shall calculate the depreciation. So depreciation is nothing but your initial price minus the tire cost minus the salvage value divided by the useful life of the machine. So initial price is 3 crore minus the tire cost is 11 lakh. Obviously your salvage value is 0 given in the question, and the useful life of the machine is 12.5 years. So now you can get your annual depreciation like this. It is nothing but 23 lakh 12,000 per year. Okay. So now you just divide it by the annual usage of the machine in hours. You can get the hourly depreciation as rupees 1445 per hour. So this is how we estimate the hourly depreciation. So this is approximate estimation because we are not considering the timing of the cash flows here. Okay. So another thing what we do in the Caterpillar method is we estimate the average annual investment. Okay. Hope you remember the formula. P into n plus 1 plus S into n minus 1 divided by 2n. P is nothing but your purchase price minus the tire cost. Okay. It is nothing but your 3 crore minus 11 lakh. 11 lakh is the tire cost. That gives you 2 crores 89 lakhs. So multiplied by n plus 1. Okay. N is 12.5 plus 1. Salvage value is 0. So divided by 2 into n. 2 into 12.5. So this gives you the average value of the machine over its useful life as you can see 1 crore 56 lakh 6,000. So over its useful life the average the value of the machine is 1 crore 56 lakhs and 6,000. Okay. So now all the other components of the ownership cost you are going to estimate it as a percentage of the average value of the machine. Okay. So your cost of investment interest is 8%, 8% multiplied by the average, this is your average value you can see. So this is the average value of the machine divided by the annual usage of machine in hours, so that you can get the interest, hourly interest. It is nothing but 780.3 per hour, rupees 780.3 per hour. Similarly, insurance is nothing but 2% of the average value of the machine. 2% of average value divided by the annual usage of the machine in hours. That gives you the hourly insurance cost is rupees 195.08 per hour, insurance charges. Similarly, your taxes, it is taken as 3% of the average value of the machine divided by the hourly usage of the machine in a year. It is nothing but 1,600. That gives you the hourly taxes cost as rupees 292.61 per hour. Now you calculate all the total ownership the cost components. So it's nothing but, so your total ownership the cost components, so you can see that one is your hourly depreciation, so other one is your hourly interest and hourly insurance charges and hourly taxes. Okay. So all these things if you add, you will get your total hourly ownership cost as rupees 2,713 per hour. Now let us move on to the operating cost estimation. So I have given you in the question that average fuel consumption factor is 0.09 liters per hour per horsepower. So based upon that you can calculate the equipment fuel cost. So this fuel consumption factor, it is derived for the particular average working condition from the handbook. According to this question, it should be for average working conditions and it is derived. Okay. So I have assumed some figures here. So you can determine the values accurately from the appropriate equipment handbook or the manufacturer guidelines. So the fuel consumption factor 0.09 multiplied by the horsepower of the engine, it's nothing but 250, and the local unit fuel cost is 65 rupees per liter. So that will give me the hourly equipment fuel cost as rupees 1,462.5. Similarly, filter oil grease, here I have given you FOG factor. So FOG factor is you are calculating the FOG factor as a percentage of your fuel cost. So the FOG factor for different types of machines are available in the equipment handbook for different operating conditions. You can take it directly, multiply by the fuel cost. Your fuel cost is nothing but 1,462.5. Multiply by the labor adjustment factor, which I told you according to the region the labor skills may vary. So we have to account for those variations by using the labor adjustment factor for the particular region. It is available in some of the handbooks. So FOG factor is given 0.119, fuel cost you have estimated already, and the labor adjustment factor is 0.8. This gives you a FOG cost as rupees 139.23 per hour. Now let us estimate the tire cost. So tire cost is nothing but the cost of the tire divided by the estimated life of the tire in hours. Okay, cost of the tire is given to you in the problem 11 lakh divided by the estimated life of the tire. So depends upon the project working condition. Okay, you can get from the equipment manufacturer or from your past records. In the question it is given as 2100 hours. Okay, you can divide it and get the hourly tire cost as rupees 523.81. Similarly, your repair factor for the machine. So the repair factor is given as 0.06. Okay, 0.06 multiplied by the initial price of the machine. Initial price of the machine excluding the tire cost. So it is nothing but your 3 crore minus 11 lakh. That gives you 2 crore 89 lakh multiplied by the repair factor. So divided by the annual usage of the machine in hours. That will give you the repair cost. Hourly repair cost is 1083.75. So now add all your operating cost components. So what are all the different operating cost components we have estimated so far? Okay, so you can see that the equipment fuel cost we have estimated, the FOG cost we have estimated, we are going to add that. Then the tire cost we have estimated 523.81 and the repair cost we have estimated 1083.75. Add everything, okay, you will get the total operating cost as rupees 3209.29 per hour. So you know the total hourly ownership cost, you know the operator wages, you know the total hourly operating cost. You add all these three, you will get the total equipment cost. Okay, so this gives you total equipment cost as rupees 6122.29 per hour. So let us continue with the same problem with the Purify approach. So as I mentioned earlier, Purify is considered as the father of the modern construction engineering. His contribution towards equipment management, equipment cost estimation guidelines are really appreciated a lot. So let us continue with the same problem now. For the previous dump truck data, let us calculate the total cost, that is the ownership plus operating plus operator cost, adopting the Purify method. So in this we have some more assumptions, like we are taking the salvage value as 20% of the initial cost. So initial cost but excluding the tire cost. So hope you remember the initial cost. Initial cost for this machine was 3 crores. Okay, yeah, it was 3 crores. Okay, and the tire cost was 11 lakhs. So we have to take the salvage value as 0.2 into salvage value will be 0.2 into initial cost minus the tire cost. So that will give you the salvage value. So now the repair and the maintenance, it is taken as the percentage of the depreciation cost here. So repair and maintenance is equal to 30% of depreciation cost, and this repair and maintenance is for the entire equipment excluding the tires, excluding the tire repair. Okay, excluding the tire repair. So tire repair is considered separately here. It is nothing but 15% of straight line depreciated tire cost. And another important thing here, the operating conditions are defined clearly, like the equipment is working at 80% of the rated power for 50% of the production cycle time. That is, the truck is using 80% of the power consumption during its haul cycle when it is traveling with the load. Okay, so that haul cycle will contribute to 50% of the total production cycle. So during this haul cycle, when it is carrying the load, it works at 80% of the rated power. The power consumption is 80%. But during the empty return cycle, when there is no load in the truck, okay, that cycle time will be 50% of the total production cycle time. So during that cycle, it is functioning at not more than 40% of the rated power. So during the whole cycle with the load, it is working at 80% of the rated power, and that cycle time is almost 50% of the total production cycle. So that means 0.8 into 0.5. Similarly, during the return empty cycle, which is 50% of the production cycle time, it is working at a power of not more than 40%, that is 0.4. So with this we can calculate our load factor. So, and the time factor is also given. Time factor is nothing but the working efficiency of the machine. How long the machine is working, say 50 minutes in an hour. Okay, that is what is the time factor. So this fuel consumption factor is given from a literature where it is where the machine is working at standard conditions, that is it is working at maximum output rate. So we have to adjust this fuel consumption factor according to this operating conditions. You have to adjust this according to the time factor and the load factor and according to your horsepower of the machine. So all these things we have to consider and adjust this the fuel consumption factor. Now let us work out the ownership cost, starting with the depreciation estimation. Purify has given two different approaches. One is the approximate approach of average annual investment method, AAI, average annual investment method, where we consider the average value of the machine over the life of the machine. So that is an approximate approach. This I have discussed under the Caterpillar method just now. So another method what we have discussed is about the time value method, where we consider the timing of the cash flows and we convert the cash flows which are occurring at different point of time, different period of time, into equivalent cash flows at a particular period using the compounding factors, okay, which is more accurate estimate. So in this problem we are going to assume the time value method, adopt the time value method, so that we can look for a accurate estimate. So first let us estimate the initial cost, deduct the tire cost from the initial cost. So the initial cost is 3 crore minus the tire cost is 11 lakh. Okay, you deduct it, you will get 2 crore 89 lakhs, okay, as the initial cost after deducting the tire cost. Now you convert this initial cost into equivalent uniform annual cost using the compounding factor. So hope you remember which compounding factor we are supposed to use. Say this is the initial cost, okay, this initial cost we are converting into equivalent uniform annual cost A. So this IC is made equivalent to A using uniform series capital recovery factor. The initial cost is converted into equivalent uniform annual cost, okay, annualized cost. We call it as annualized initial cost using uniform series capital recovery factor. So the initial cost is nothing but your 2 crore 89 lakh what we have determined just now after deducting the tire cost, okay, 2 crore 89 lakh multiplied by your uniform series capital recovery factor, which is nothing but I into 1 plus I whole power n divided by 1 plus I whole power n minus 1. Okay, the interest rate you know it is nothing but 8% and n is 12.5 years. So you can get the annualized initial cost as 37,41,844.41 per year. So we have converted the initial cost into annualized initial cost using this uniform series capital recovery factor. Now let us move on to the salvage value. So now I need to convert the future salvage value, okay, the salvage value into equivalent uniform annual cost. So the salvage value will be converted into equivalent uniform annual cost. How to convert it? Using uniform series sinking fund factor. Uniform series sinking fund factor. So hope you remember this. The sinking fund factor is nothing but I divided by 1 plus I power n minus 1. You multiply that by the salvage value. Salvage value is nothing but 20% of the initial cost minus the tire cost. So now you substitute the values, the interest rate and the useful life of the machine n equal to 12.5. You will get the annualized salvage value as 2,85,968.88 per year. Now you can calculate the hourly depreciation. Hourly depreciation is nothing but the difference between the initial cost minus the salvage value, and you are going to divide it by the annual use of the machine in hours, so that I can get the hourly depreciation directly. So your initial cost, annualized initial cost is nothing but 37,41,844.41 minus your salvage value. Annualized salvage value is nothing but 2,85,968 divided by annual use of the machine in hours is 1,600. So this will give me the hourly depreciation as 2,159.92 per hour. Now the other components of the ownership cost, the insurance, taxes, storage, everything, we are going to calculate it as a percentage of the initial cost minus the tire cost. So insurance percentage is 2%, 2% of the initial cost minus the tire cost, okay, divided by the 1,600 hours, that is annual usage of machine in hours. That will give you the hourly insurance cost as rupees 361.25 per hour. Now let me calculate the taxes. Tax percentage is 3% of the initial cost minus the tire cost, okay, divided by the hourly usage of the machine in a year. Okay. So, that will give me the hourly taxes as rupees 541.88 per hour. Now, add the total hourly ownership cost, add all the components. So, one is here the depreciation. So, you got the hourly depreciation is 2159.92 plus the insurance cost is rupees 361.25 plus your taxes 541.88. So, if you add everything, you will get the total hourly ownership cost as rupees 3063.05 per hour. Now, let us estimate the operating cost. So, first let us estimate the consumable cost, the fuel cost. So, this fuel consumption factor, as I told you, it is given for a standard condition for maximum output rate condition. So, this consumption factor, hope you remember what is the fuel consumption factor. So, it was 0.14 liters per horsepower per hour, 0.14 liters per horsepower per hour. So, this fuel consumption factor I have to adjust according to the operating factor in my project condition. So, operating factor is nothing but the product of time factor and the load factor. Okay. So, now let us estimate for the Hall cycle as well as the return cycle and the load factor, because the power consumption is different for the Hall cycle with the load and empty the return cycle without the load, the power consumption is different as discussed in the question earlier. So, and the Hall cycle it will contribute to 50% of the total production cycle, and the return cycle it will contribute to 50% of the total production cycle time. And during the Hall cycle the power consumption is 80%, and during the return cycle when the truck is empty the power consumption is 40%. So, multiply the time multiplied by the power consumption ratio, you will get the load factor. So, now add both 0.4 plus 0.2 for the total production cycle, you can get the load factor. This is your load factor. Okay, this is your load factor. Now, the time factor is directly given, it is nothing but the working efficiency. Your machine is working for 50 minutes in a hour. Okay, 50 by 60 equal to 0.83, that is the working efficiency of the machine. Now, the operating factor is nothing but time factor multiplied by the load factor. Okay, load factor is 0.6, time factor is 0.83, your operating factor is 0.5. Now, you adjust your fuel consumption factor, that is 0.14 liters per hour per horsepower with the operating factor and the horsepower of the engine. So, we are going to adjust it according to your machine and according to the project working condition. So, operating factor is nothing but 0.5 and the horsepower of the machine is 250 and the fuel consumption factor from the literature is 0.14. So, the final fuel consumption per hour is 17.5 liters. Now, we have to estimate the hourly cost of the fuel. So, for that you have to multiply the hourly fuel consumption by the unit cost of the fuel. Unit cost of the fuel in that local price is 65 rupees per liter. So, when you multiply it, you will get the hourly fuel cost as 1137.5 per hour. Now, let us estimate the other consumables FOG, filter, lubricating oil and grease. So, as I told you, there are different ways to estimate it. In some handbooks, we get the FOG factor for different equipments for different operating conditions. This factor, it can be expressed as a percentage of the fuel cost. So, this FOG factor is derived for a particular equipment type for the particular working condition. Say in this case for the dump truck, say for the average conditions, I have assumed the value as 0.119. Okay, these are just approximate assumptions. You can take it appropriately from the handbook. So, then the fuel cost we have derived earlier, hope you remember, 1137.5 per hour. So, you multiply the fuel cost, then labor adjustment factor. See, as I told you, the labor skills will vary from place to place or region to region. So, in some handbooks we can also get the information on the labor adjustment factor for the particular region. Then accordingly you can adjust your factor according to the labor available in the particular place. So, you will get the FOG cost as rupees 108.29. Okay, so now we have estimated the consumable cost. Now, let us move on to the estimation of the cost of tires. You know the tire cost, it is nothing but 11 lakh, and what is the estimated life of the tire for that particular project condition, you can get it from the manufacturer or based upon your past accounting records, you can get this information. This value is given directly in this question as 2100 hours. So, 11 lakh divided by 2100 hours gives you the hourly tire cost as rupees 523.81. Now, calculate the tire repair cost as 15% of the straight line depreciated tire cost. So this is also given in the question. So if it is not given in the question, you can assume the tire repair cost as 15% of the tire cost. 0.15 into the tire cost is 523.81. So that gives you 78.57 per hour. Now calculate the total tire cost. So total tire cost is nothing but your tire replacement cost 523.81 plus your repair cost 78.57. If you add both, you will get the total tire cost as 602.38 per hour. So in this, the repair and maintenance of the equipment excluding the tire is expressed as a percentage of the depreciation cost of the equipment. So the depreciation cost of the equipment is 2159.92. Okay, hope you remember, we have estimated the depreciation cost as 2159.92. So that value we are going to use here to find the repair and maintenance cost. It is 30% of the depreciation cost. So that will give me the value as 647.98 per hour. Now the total hourly operating cost, you have to add the fuel cost, fuel consumption cost, your FOG cost, your tire cost and your repair and maintenance cost. Okay, this is your repair and maintenance cost of the equipment. So this gives me the total hourly operating cost is rupees 2496.15 per hour. So already we have estimated the total hourly ownership cost. You add both ownership and along with the operator wages, which is given as 200 rupees per hour in that particular place. So it varies from region to region. Okay. So when you add all these three, we can get the total cost of the equipment as 5759.2 per hour. Okay. So using the purify approach, particularly using the time value concept, we are derived the value as 5759.2. So earlier in the caterpillar method, I think the assumptions were different and the value derived was 6122.29. So which method we are going to use for our particular company for the cost accounting purpose is totally it's a business policy. Okay, it's totally left to the company. There is no constraint on any company owner or the project estimator that we have to follow only this particular method to estimate the equipment cost. There is no such constraint. It is totally left to the freedom of the particular company. It depends upon their company policy or the business policy. So basically the choice of the method of the equipment cost estimation is business policy decision mostly. Every company has its own method, internal method for arriving at the hourly equipment cost for the accounting purpose. Then let us summarize what we learned earlier in this lecture. In Caterpillar method, we found that it is based on average annual investment method, which is approximate. And the information on the consumption of fuel, FOG, repair cost, everything is available for different equipment models and for different project conditions with the definition of the project working conditions from the Caterpillar handbook. Similarly, you can find this in many other handbooks which are available. So lot of sources of literature are there to get this data. So most of the equipment suppliers, they provide an equipment handbook with sufficient data on these parameters. And the approach, the time value method, considering the timing of cash flows using various compounding factors, gives you the more accurate estimate. So with this, we have come to the end of this lecture 5. So these are the references which I have to use for this lecture preparation. As I told you, there are so many equipment handbooks. One such equipment handbook I have cited here is by US Army Corps of Engineers. You can try to go through all these handbooks so that we can get the information on the various factors which I have mentioned, the fuel consumption factors or the FOG, labor adjustment factors. Okay. And they have also given you the illustrations on how to do the equipment cost estimation. Okay. So I advise you to go through some of the equipment handbooks to get more information in this related to this topic. Thank you.